So one of the ways that I work with students and others is to design puzzles for them to play with. Here's a simple puzzle. These two pieces go together and they make a tetrahedron. And it's much, much harder than it looks. Some people take a half an hour or more to put these two pieces together because I've optimized them to be as hard as possible. I've applied mathematics to make them difficult. But the key idea in my mind is that people need to get comfortable with solving new challenges where they don't know how to do it. And as you move up in mathematics, people ask you to prove theorems that no one's ever proven before. And to get comfortable with something that you don't have a cookbook method, it's great to play with puzzles and try different things and to fail and fail and fail and fail. And then you try something new and eventually something works. And that perseverance, that skill, that ability to hit things from different directions is essential. When people work on a puzzle like this, they're building up some kind of ability in their mind that enables them to get better at it. At first it may take them an hour to solve this, but then I'll give them some other ones and they'll get those faster and variations will get faster. So something does build up with practice. What I have here, because it's a star and it has these 5 magnets in it, I can put it back together different ways. You can turn it, there's 5 different ways it goes back together. And it's a wonderful puzzle to visualize, how does this roll? When I put this on a surface, how does it go? And it's a simple object that you can look at, and yet it's so hard to visualize. And it's great to do visualization exercises because there's certain kinds of problems that are best solved by seeing in your mind a kind of a structure. And by practicing on as many different visualization problems as possible, you can build that muscle in your mind. This is something which I brought, which is a rubber band tied in a knot. So this started out as a simple loop, but then I did something which turns it out to have a knot in there, which is fundamentally unremovable. And it's a wonderful puzzle to think about. How can you create a knot in a rubber band? A simple way would be to take a rubber band, cut it, tie a knot, and glue it back. But I didn't do that. There's another solution, and I'll leave you with this as a challenge to ponder over. How do I put a knot in a rubber band? And if you want the solution, you can go to georgehart.com and you'll find the answer.
One of the best ways to practice actually on math is through an exciting math app or a video game. They give kids loads of opportunities to practice and they're enjoying it at the same time. So I, say to particularly elementary teachers, get rid of those boring worksheets that turn kids off math and get them working on this app where they're using the same math facts and numbers, but they're really engaged and enjoying it.
This is game 2048, so it's basically just addition.
What's the goal of the game?
The goal is to get highest score over the tile 2048.
Oh, okay.
And
I see. Okay.
Yeah,
so show me how. Go ahead.
It's basically you want to get the highest number possible. So to do that, you have to do 2 plus 2.
2 plus 2?
Yeah, 2 plus 2 over here.
Yeah.
Which slide down makes 4.
Yeah.
And now you have to try to find more tiles that match. And I can make a 4 from
another
here.
4.
Yeah. Then I can make
another
8 and 4 over here.
Yeah.
I can slide this way to make 16 and 32.
32 to 2 16s.
Yeah, and slide this way, then I can
32 and 32. Yeah.
I can make.
Oh, you got to get a 64.
Yeah.
There's one. Okay, good. Powers of 2, though.
Yeah.
All powers of 2.
Well, I'm using Minecraft to build like a model of the Coke so I can find out the exact amount. And I'm also doing multiplication and like normal math to find out how it works. This is the app called Minecraft. Minecraft is like kind of like a universe made out of blocks. Because this is some major league educational gaming.